Hello everyone, welcome to the video session of the doubts and clarifications what your students will have. Okay, thank you for responding well and asking me these following doubts. There are a few of confusion you have in this chapter. Of course, it is a little wide chapter, that means it is a huge chapter which you need to know. But few basics which I tried to explain in those videos might have been left out. I'll try to cover up in this video. Okay. So please go ahead if you have still more doubts. Do not hesitate to ask any more. Yeah. So we'll begin with the first question of the doubts which my students have asked through messages and all that. Okay. So fine. You can ask doubts in whatever way possible. Fine. Go ahead. So here we'll be learning about the first thing. Like you have, I have explained the first meaning of what is a light. I told you all what is a form of energy. Light is nothing but a form of energy. But still, students have a little confusion. What is this light actually? Okay, so I'll explain still more in detail. What is this actual meaning of light and what is it light actually? So what is nothing but, you know, the natural form of light is nothing but the sunlight. Correct? So sun is the main source of light for this earth. Okay, whatever the bulbs etc. electricity are the secondary. The first thing you need to know is about the daylight which you see over here. So sun is the major source, of course, and the sun emits various of radiations. I mean, lot of radiations. Radiations such as UV radiations, ultraviolet radiations, what I mean, infrared radiations and X-rays, gamma rays, and all these are harmful radiations, and few of them are useful for us as well, and few of them are harmful for us. And all these radiations, one among them is a visible radiation. I will tell you what it means. Okay. So sunlight, I will tell you about it. Sunlight. We're talking about the sunlight. It's not about only light. Okay. Light is a form of energy, you know. But the major sun source, that is the source of sun, is the nuclear energy that we will be learning in the next coming chapter. What is sun and what is it actually and how is it getting into energy and all that. But presently just understand that sun is the one which is emitting out a lot of radiations to this earth. There are many such radiations. I'll write few examples maybe. Okay, UV radiations. You know about this, that is ultraviolet radiations, and infrared radiations, that is called as IR radiations. Then comes visible radiation. Visible rays or visible radiations. Then comes about gamma rays. I don't know this. You need not remember all these things. Okay, you need not remember all these names or whatever it is. Gamma rays or gamma radiation. Then it is about the beta, and then the X-rays. Okay. So all of these, like there are many more. Okay, there are many more set of radiations which the sunlight will emit, or the sun will emit. So among those, there is something called as a visible radiation. As among these list of radiation, something called as visible radiation, and in that, the rays which are visible to our eyes, or the ones which is easily detected by a human being or animals, living creatures, that is called as the visible rays. Okay, that's we have named it as visible rays. Okay? We have named that particular ray which is visible to us as visible rays, and in that, a part of invisible rays are nothing but light rays. Okay, a part of it is nothing but light rays. So visible radiations are comprising of light rays, and this light rays is nothing but a form of energy. Similarly, we have heard about the heat energy, water energy, all those things like that. Only this light is also a form of energy. So when these light rays fall on an object, okay, then there are a set of light rays which will fall on an object, maybe a chair, okay, something like this, chair or whatever you want to call it as. So light rays will fall on this, and wherever some person is over here, maybe this light ray will reach him back after falling from the chair. And because of this particular procedure of light rays falling on an object and then reflecting back to our eyes, it gives us the sense of vision. Clear? So light rays, when it is made to fall on an object, it gives the sense of vision. So one example I can give you all is, imagine some phone, or not phone, maybe some pen or pencil has been fallen under the cot, whichever you're sleeping, or maybe under the chair. Okay, there is a complete darkness under that particular seat, whatever, under the seating, whatever you're sitting in. So you need to see that object. What do? You take a torchlight and then put on that, which means a light ray will pass through that object and pass to that object and then reflect back to your eyes. That makes the object visible to your eyes. Clear? So that is why this light rays are necessary for us, and this is the basic idea, and this is the actual meaning of light, which is convenient for you. Okay, so we'll move on to the next question. Speaking of reflection, student had a little confusion about the reflection topic, so I'll re-explain it. We'll come across again the things what we have, meaning of reflection and what is actually the process of reflection. Okay, so it is nothing but reflection is when a light ray falls on a surface, okay, on a reflecting surface, to be more specific. Okay, if a light ray falls on a reflecting surface, which means it does not absorb the light, nor does it allow the light to pass through it. Okay, that is what a reflecting surface means. A reflecting surface is a surface which does not absorb the light, nor does it allow the light rays to pass through it, which is not transparent. That is what I mean. So, if at all, such a surface is called as a reflecting surface. What it does, when the light ray falls on it, it will just push the light ray away from its surface. So that is simply a rough understanding about reflection. So let me see what is the procedure happening over here. So imagine the light ray randomly falls on that surface. This is a reflecting surface, and the light ray will come and fall on that particular any point on that surface. So there, at that particular point itself, let me assume there is a normal plane. Okay, let me assume this is an imaginary plane. Okay, there is nothing actually present over there. I'm just imagining or drawing a line straight to that. Drawing an imaginary line, imagining that at that particular point, at where it comes and falls. And that point, what happens is the light ray will be pushed outside. As I told, this is a reflecting surface, it will be pushed outside. And this pushing outside, or the throwing of the light ray, or reflecting of the light ray, that is reflecting ray, this is done, follows certain rules. That this is called as a reflection. Okay, so this is the incident ray, incident light ray. This one is the reflected light, reflected. Okay, reflected ray of light, and this one is an imaginary normal to the surface. Imaginary normal. Okay, imaginary. I tell it imaginary because it is not actually present. We are writing it for our reference. So why I am doing that imaginary plane is because to tell the first law of reflection. The first law of reflection tells us that the angle of incidence. Okay, angle of incidence. Let me talk what is angle of incidence before completing that sentence. Angle of incidence is nothing but it is an angle made with respect to the imaginary normal. Okay, angle made by the incident ray, with respect to the imaginary normal is called as incident angle. Okay, incidence, angle of incidence, that is I, is always equal to the angle of reflection, angle of reflection is always equal to the angle of reflection, and that angle of reflection is nothing but angle made with respect by the reflected ray with respect to the imaginary normal, and that is indicated as R. Okay, so this is the first law of reflection, which says that the angle of incidence of an incident ray with respect to the normal, that is imaginary normal, is always equal to the angle of reflection with respect to the same normal. So what does it actually mean is, with whatever angle I am pointing the light, okay, I am pointing the line with whatever angle, that imaginary ball is there, you imagine. With whatever angle I point it will reflect back in the same angle with respect to the same normal. Okay, so which means this bending can be depending on this one. If I decrease this angle, this also decreases, like this. This also decreases. Clear? So that is what it means, that the angle of incidence is always equal to angle of reflection. So that is the first law you learn about the reflection. The second law you need to know about is these. That is nothing but the incident ray the normal to the surface, and a reflected ray. These three things are there. Now, all of them, that is incident ray, the reflected ray, R means reflected ray, don't get confused, and the normal to the surface, all of them lie on the same plane. Same plane. Okay? That means this is also on the board. Okay, I am explaining this. This incident ray is on the board. It will be reflected on that surface of the board itself. It won't pitch out and come outside the board. That is what it means. It means that suppose if I am putting the light ray here, it will pitch straight itself in the same plane, same particular line. It will not pitch outside, that side or this side. Okay, that is what it means. So if at all there is a plane here, the light ray is coming here, it will pitch right in front of it, exactly in the same straight line. It won't divert outside or this side. So this is the meaning of the second law. Okay, so this way determined a lot of experiments were done, and that's how they concluded into these two laws. So what do you mean by normal to the surface is nothing but it is an imaginary line or imaginary plane drawn perpendicular to the reflecting surface. This is the reflecting surface. Reflecting surface. Okay. This is the reflecting surface, an imaginary line or a plane drawn perpendicular to the reflecting surface is nothing but a normal to the surface. Okay, and you know, incident ray, normal ray, and the reflected ray all will lie on the same plane itself. So that is about the reflection topic, and if you have still confusion regarding that, please let me know. I will try to explain it in a different way as well. Okay, so we'll move on to the next question. The third question students have had is nothing but mirrors and glasses. What actually these mirrors are, and what are these glasses, and why can't we learn? Why are we not learning about the glasses in this chapter? We are kind of learning about the glasses, but those are like spherical glasses, that is lenses. I'm sure you have seen those videos. That glass is nothing but you have learned about the refraction as well, in which the two spherical surfaces are joined, and then the refraction takes place, that is bending of light takes place in different ways. So that was about the glass. Glass means it is completely transparent. Light will pass through it, yes, and there is hardly any kind of reflection taking place. But the refraction takes place through a glass. Like plain glass, not much of a refraction takes place, because you know the glass. Suppose you have if I keep a glass right in front of me, you have my eyes. These are the glasses what I'm talking. So yes, the refraction is taking place in these glasses because these are lenses, more to be specific. If it was a proper plain glass, there is absolutely no refraction taking place. That means there is no bending of light taking place. Just light will come and exactly it will go in the same straight line. Yes, if in case it was a bend like this glass, you can see a slight bend in this. I don't know how much you all can see, but in case you all have a glass at home, that the eyeglass at home, it will have a bend in it. It's something like a lens, a thick lens or a thin lens or a spherical lens. So that is what. It can be concave or convex depending on what it is, and which we'll be learning in detail in the next chapter that I will be sending the video soon. So in that we'll come to know what are these lenses and these eye defects and all that. So we'll learn with that. Whether it is there for your exam, that is the final exam, whether it has been taken out of your syllabus, it is none of your business. Okay? Just don't worry about the syllabus, what is there for the exam or not there for the exam. So you just study everything what is there in your textbook. Mainly because the people whoever are preparing your question papers will yes, of course they will have the syllabus in their hand, but they are very lazy to prepare a new questions. Okay, what they will do is they will copy and paste the old questions, whatever is already present. So while copying and pasting, there is a chance, I'm not telling possible, like I'm just telling it is possible that they can copy and paste a question which was already there for the previous syllabus, and they are just copying and pasting it without actually completely reading through it or what. So that time you will be confused when you read that question. This topic you have never read it before. For example, the defects in eyes, which is said to be excluded out of the syllabus. I don't know how sure is that. I'm not bothered about it. I just want to complete the full portion, and I want you all to study the complete portion, because that topic might appear in the exam and you cannot question anybody in the exam hall. You just have to write the answer. Okay, whether you're getting us grace marks for that or not is not possible. You will not be able to question once you finish writing the exam. So don't take a chance, and I want you to study everything and write everything in the final exam. So be prepared for a complete syllabus. Do not check the syllabus and skip the topics, whichever is not there and all that. So these topics, whichever is there in the textbook, we will stick on to those topics and complete it clearly. Okay, any silly doubts you have, ask me in any number of times. We have a lot of time. I'm just telling that, not telling that we don't have time or something like we should hurry up or something. We'll go slowly because anyway of school are being delayed a little. So your questions, I don't know, it's done in online, whatever it is, but the slow time, because you can sit at home and study everything. So give your best. Okay. So any doubts, please go ahead and ask me. We'll clear it out using a video, or maybe in some source we can clear out all your doubts. We'll do it fast from now. Okay. So this is what I'm trying to explain, is nothing but a mirror and a glass. Mirror is something which will completely reflect what the light rays or whatever the images it is falling onto it. It will reflect it completely. Glass will not reflect things. It will only partially reflect. You can see, suppose there is a glass in front of you, you can see your image partially, not completely. So there is some kind of a reflection, yes, but maximum is just put outside that mirror. That means it is completely gone out of it. So the rays pass through the glasses, whereas the rays reflect from the mirrors. So that is the major differences between the mirror and the glass. Along with this itself, I want to explain the topic which few students have a confusion: spherical mirrors. Okay. To understand what is a spherical mirror, I want you to know the two types of mirrors what is present. Mirrors, which are two types, obviously you all know it, but still, let me clearly tell you something. One is a plane mirror. Plane, and one more is a spherical mirror. Okay. Plane mirror and a spherical mirror. Name itself is 100% clear. Plane mirror is nothing but completely straight. Yes, which is in your house, which in your wardrobe, you can just see yourself clearly. That is nothing but a plane mirror. Plane mirror. Spherical mirror is nothing but a bent in shape. Okay, little bend, which means, imagine, I will detailedly explain. I hope plane mirror is clear, and we are not going in much with depth in this chapter for our plane mirrors. Okay, so we will be dealing only with the spherical mirrors initially of this chapter. So imagine the spherical mirror, complete sphere of a mirror. Okay, sphere of a mirror. I will draw a sphere which is made up of the outer surface is a mirror. Okay, this is the reflecting surface. You can imagine a sphere, completely circle, the ball. Okay, a ball, which is outer surface is completely reflecting, which looks like a mirror. When you look into it, you would see yourself clearly. That type of ball. Okay, then a piece of it you cut. Okay, a piece of it you cut. That means this portion is not there. Okay, this portion is not there. So only remaining portion is just this. I have cut this portion from a spherical ball of a mirror. I have cut this much of it, and only the remaining portion is this much. Okay, I will try to do this way. This much remains. This much is the one which remains of that particular spherical ball. That much remains, and in that, this portion is the reflecting portion. This side portion is the reflective portion. This particular dim portion, what I am trying to draw, is nothing but the non-reflecting portion. Okay, non-reflecting portion, and this blue colored line is nothing but the reflecting portion. So brighter one is reflecting, this dim one is nothing but the non-reflecting portion. To understand more about the details of that spherical mirrors, there is something, this particular point, AB is there, no? This AB. Suppose if I see it in this direction, that is completely in the side view direction, it will look like a circle. It will look like a circle, which is outside like that, bulged outside like that, because it is a part of a sphere. No, I have cut that sphere. It will look bulged outside, and this particular area or portion of whatever it is called as the aperture. It's called as the aperture, or I can tell the effective diameter. This particular curve, how much ever is available for reflection, is called as the aperture. Okay. The effective diameter, I don't know, they might in the textbook they have given just as a diameter of the portion or what, I don't know, but you remember it is nothing but the effective diameter of the surface of a mirror is nothing but the aperture. Okay, so remember it like that. Then the middlemost portion, that is the midpoint of that aperture, is called as the pole. This P is called as the pole. Yeah, so middlemost portion or the midpoint of that aperture is called as the pole. Okay, so then a line is imagined to pass through. It is not actually there. A line is imagined to pass through the pole. Line is imagined to pass through the pole, and that particular line is called as the principal axis. Okay, that particular line which passes through the pole is called as the principal axis. And along the principal axis, there comes a point. Suppose, imagine all of these light rays. Suppose all the light rays are coming here like that. Okay, these are the light rays, and they will reflect. They will reflect like that. You know the concave mirror concept, correct? No, the diverging of mirror, the diverging of light takes place, and that diverging of light is assumed to be meeting at one point in the opposite direction. Okay, assumed to be meeting at one point in the opposite direction. This is assumption of light. Okay, because the light rays do not actually come back, but they move away from the space, away from the spherical mirror. We assume that it is meeting in the opposite direction, and that meeting point is called as the focal point, focus point, focus point. Okay, this particular thing is called as the focus point, and the distance from this focus point to the pole, distance from the focus point to the pole, is called as the focal length. Okay, it's called as the focal length. I write it as FP. Okay, focal length. This FP, this distance is nothing but the focal length. Okay, I know the diagrams looks just too much, but while I'm explaining only, you make a note of all these things. So this particular distance is focal length, as I told you, and focus is on the principal axis again. This is the focus or focus point. After this comes an imaginary point, okay, an imaginary point of which this whole spherical mirror, no, it was a complete circle before, and the center of that imaginary circle of which this spherical lens was a part before, that is called as center of curvature. Okay, that is called as the center of curvature. So that is the imaginary center of the imaginary sphere from which we have cut the spherical lens or taken the part of that lens. Not lens, sorry, mirror. Taken the part of that mirror. So that is nothing but the center of curvature. After center of curvature, obviously, we need to know about this particular distance from the center to the pole. That is called as the radius of curvature. Okay, radius of curvature. You will have all these details in your textbook. Please go through them and let me know if you have any more doubts regarding these topics. These are important topics regarding the spherical mirrors, and you need to understand these in depth and without even just checking anything. If they ask what is an aperture, you should be able to imagine this diagram and then explain. Okay, rather than simply by having it is the effective diameter, something nonsense. So instead of that, I want you all to imagine this diagram, and this particular explanation should come to your mind, and you should be explain this in a interesting way to whomever asks you what is a spherical mirror. Tell me how to remember all these things when it is so difficult. So I just want you all to take few time and like 5 minutes, take this example and give them a proper brief explanation if anybody asks you. Okay, that is how you need to study. Always prepare yourself to teach somebody, so that time you will understand much better. Okay, fine. So this was about the spherical mirrors. We'll move on to the next topic here. 1 minute, sorry. I just wanted to tell a brief idea about the plane mirror as well. Suppose this thing, plane mirror, this focus point will be at the infinity. This point is there, no? That thing will not at all be available. Why? Because this mirror will be completely straight. Correct, no? This is the reflecting surface, the brighter one reflecting, and this is the non-reflecting surface. Suppose the light rays enter, light rays fall on them. They will travel back in the same path again. Why? Because there is no bending in the mirror, and obviously there is no kind of a bending of light ray taking place. So which means the light ray will completely go back. Even if I assume that it is moving, even if I extend it in the opposite direction, these light rays are not meeting at any particular point, and hence there is no focus point for this. And learning about plane mirrors is out of this topic of book, so we don't know these things to make more calculations about the plane mirror. It is simple as that. There is no bending taking place. That's why the light rays just travel in the same straight line. Clear? And always remember, in the mirrors, the image is formed always behind the mirror. Okay, behind the mirror. Never confuse yourself saying that screen and the mirror is same thing. A screen is something, the projector screen, suppose if I assume, a projector screen is something where the light rays are made to fall, made to intersect. Okay, light rays are made to intersect. The light rays of the image is what I am talking. After the reflection or refraction of light rays, it will be made to fall on that, and the image is formed on the screen. Whereas mirror is nothing but the light rays are made to fall on that. The light rays will come and fall on that. There is no intersection taking place of light rays. If you can see, all the light rays are coming parallelly. There is no absolute intersection taking place of these light rays. No, never. So what happens here is the images which is formed, which will be much behind the mirror, not on the mirror. Yeah. Whereas the image is formed on the screen, the images are formed much behind the mirror. Yeah, that's the confusion you have. So I hope I have cleared it, or if not, let me know if anything more I can explain. Thank you. So the last doubt I found from the students is, and the major confusion, like almost all students are asking the same doubt about the image. So what actually is image? So almost everyone is having the doubt regarding this image. That is two types of images, which is virtual and real. So huge confusion in this. I'll try my best to clear this confusion in this particular video. Then we'll see. In case you all don't understand, I hope Sunday the classes will be open. I can show you with the help of an experiment maybe, or explain it in even more detail. So when face to face, it will be easier to explain face to face. Then we'll see. Then you can question that time only at home and all that. But anyway, I will try to explain the best about the differences between virtual and real images and what actually the image means. So all of these confusions I try to clear in this video. So telling about the meaning of image. So I have told you, and I have written clearly that you all want meaning of image. You all don't want the definition of image. Okay. So I tell you what is an image. So I will tell it in the scientific way only. So let us understand as much as possible. An image is nothing but if the two light rays intersect, an image is formed. If the two light rays intersect, an image will be formed. That is what I mean. So over here, what is happening is, suppose you take any object. I will do it and I will explain it in a detailed way. Take a lens. I will take a lens and draw the principal axis of that lens. And suppose a person is here. Okay, a person is there here. Any random place, like any far from the focus point. The focus point is here and he's away from the focus point. The center of curvature may be much far, and there is optic center, all these things. I mean, one thing I got it out from one of the students is, why am I getting the image? Suppose it was supposed to be beyond the center of curvature, and I'm getting the image is formed between the focus and the center of curvature. So first thing you need to know about while drawing the ray diagrams is, you need not maintain this distance exactly as it is. You are learning the ray diagrams. You are not creating a ray diagram of your own. So what you are going to do is, the diagram whichever is given in a book is the experimental diagram. That means the experiment is done. I have sent the videos of that experiment. Experiment is done and the results are obtained of that. So that is what I am talking about in these videos. So here it is not about the theoretical measurement. You are not taking a scale and then measuring the focal length and all that, marking as a number line and then drawing it. It's not like that. It is an experimental determination. So if at all the object is placed at between the center of curvature and the focus, the image will be formed between the center of curvature and the focus of the other side itself. That is a rule, and that is the experimentally determined result. You cannot change that result. Clear? So while drawing theoretically, you might get something else. That means it can come beyond C, beyond center of curvature, or beyond the focal length while drawing. That is because of your mistake of drawing. That is, you have taken maybe the distances in that way, or the number line, some mistake is there, or the thickness of that particular lens is something. So because of that, you are getting that theoretical answer wrong. But this is not a theoretical drawing. It is a practical drawing, which is the results are obtained out of experimentation. So understand that, and then so that is what the result which is given in your book. That is the result of that refractive ray experiment. So I try to explain what is this images formation. Okay. So here, suppose the person is here and the light ray will travel like this. Okay, there is a lot of light rays. There is a lot of light rays will pass through, and one such light ray will be parallel to the principal axis. Another such light ray will be traveling through the optic center. So I will concentrate on only these two rays. Yes, of course I can concentrate through all the other light rays as well. We are just concentrating on two particular lines, that are two particular light rays which is passing through that person. This one is the one which is parallel to the principal axis, and one more is passing through the optic center. So these light rays, after refraction, will pass through focus. That is, one is parallel means it will obviously pass through the focus according to the rule. Okay, according to the rule, it will all pass through the focus. So over here, it will pass through the focus point, and this one, optic center, will go undeviated. So that is what I am talking here. All the light rays will come like that. Okay, here this particular thing will go undeviated. So optic center light ray will go undeviated, and the image is formed at this particular point, meaning in between the center of curvature and the focus. Okay, center of curvature and the focus. That means you can see that the head of the image, the head of that person will be inverted in this way. Okay, let's not concentrate about inverted and correct images. I'll tell you what it is later. But now concentrate on what did I just tell about the image. Image is nothing but the formation when the two light rays intersect. After refraction, suppose from the particular person or object, the light rays travel and they undergo refraction and they meet or intersect at the other direction. At that particular point, the image is formed. Okay, that is what I mean. So an object form, a creation formed of intersection of two light rays is called as an image. Now, so image is understood, I hope so. If not, I try to clear it out in few more ways. So for now, let us say, suppose if the two light rays actually intersect. That is in this case, yes, it is actually intersecting. Correct? All these light rays are actually intersecting at this particular point. Okay, at this particular point, I can call that as A dash, B dash. Okay, at these particular points, the light rays are actually intersecting. All these light rays are intersecting. So that's how I can tell that this is a real image. Okay, this is a real image. Why? Why? Because the light rays actually intersect. Actually intersect. The light rays are actually intersect. Now you understand a little better what I'm trying. Why am I stressing on the word actually? Okay, while I'm stressing on that, let me concentrate. Let me touch that. I'll take another lens. Okay, I'll take a lens. I'll draw the lens, and suppose the focal point is here, and the person, whoever he is, like he will come much closer to that of the focal length, which means he is between the optic center of that one and focal point. So one of the light rays, as you know, will consider the light ray which is traveling parallel, and it will bend like this in some direction like that. One more will travel like that and bend in this direction. So this is the thing, a rough idea we are going to draw. So light ray will bend like that. Okay, so this we have learnt in the ray diagrams, yes. So what will happen? Like no matter how much time this light rays pass, like no matter how they pass, they will just diverge away from each other. They will never intersect. Correct? These light rays will never intersect no matter how much far they go. But let us assume that these light rays extend in the opposite direction. Okay, these light rays extend in the opposite direction. So first of all, these are the actual light rays. Okay, these are the actual light rays which is passing after refraction. After passing through the refraction, it is just diverging away from each other. They will never intersect in the opposite direction. But whereas they appear, which means they appear. I'm again stressing the word appear because it is not actually intersecting behind also. It is not intersecting behind. They just appear to intersect in behind, which means the image is formed in the behind direction. That means before this side of it. I'll tell in a easier way, which means appearing means the light rays actually do not meet. They do not meet. They just appear to meet at each other. They just appear to intersect at a point. And such type of an image will be formed. You know, intersection of two lines or meeting up of two light rays is nothing but image formation. And imaginary light rays which intersect each other, or the light rays that appear to meet each other, will create an image called as a virtual image. Okay, virtual image. And this virtual image is not actually there. It is not actually there. That's the meaning virtual. Virtual means it is imaginary. Yes, it is not actually there. It is just can be seen if I am looking from here. I can just see it if I am looking from here. Otherwise, it is not visible at all. So from here, if I see these two light rays are appearing to coming from some point, and that is the one which is creating that image. It is not actually formed. Which means I can only see this image. I cannot capture that image. I cannot put it on a screen. So why? Because these light rays are not actually there. They just appear. They just appear to be like that. They just appear to be intersecting from that point. So I'll tell in a better way. Suppose if I put a screen here. Okay. Suppose if I put a screen here, a white background or something, or a black background, whatever it is, like outside. It's three-dimensionally drawn like this. A screen here. In a real image, an image can be obtained on a screen. An image can be obtained on a screen. But whereas, no matter where I put the screen for the virtual image, this image will not be formed on the screen. You can only see from here. Yes, you can only see from here. The actual image, the formation of image can be only seen. It cannot be got on a screen. Such type of images are called as virtual image. Here. So try to understand as much as possible from this one, and from this you can clearly know that the real images, since it is formed on the opposite side and it is formed by the actual intersection of rays, and here it is formed by the light rays. Okay, appear to intersect or meet. Intersect or meet at a point. Appear. Word appear seems to be important here, and it actually intersect seems to be important here. So that is about it. Here you can see these are formed in the same direction, and that's the reason the virtual images are direct, and since it is formed on the opposite side, the real images are inverted. Okay, so you have a certain question doubt over here also. One of the student had doubt. Why are the virtual images correct? Why can't they be inverted? Because if they were supposed to be inverted, they would have to be formed on this particular side. And this particular side, there are no light rays which is meeting at a point. Image is not formed at all. So image will be formed only on the opposite side. That is, image appear to be formed on the opposite side. And that imagination image, that imaginary image, is called as a virtual image, and it is always erect. So one example I can give for this virtual image is the one which you are looking at yourself in the mirror. So the image is formed much behind the mirror. As I told you, plane mirror, yes, the image will be formed much behind the mirror. That is, it is appeared to be forming. You cannot, even if you keep a screen much behind the mirror, you will not be able to obtain your image in that screen, because light ray itself is not traveling that way. You only feel that the light rays are coming from that point, and that's the reason you just feel that there is an image of yours that is formed much behind the mirror. If you keep a screen also, you will not be able to catch that image of yours in the screen. Whereas you can, if at all you are looking at yourself in a lens, through a lens, such a way that it reflects and meets at a point, if you lean on the point where the rays are actually intersecting, that is the image can be caught on the screen. Image will be formed on the screen. And such an image form is inverted, and that's the reason it can be called as a real image. One example for that real image is nothing but the cinema theater movies which you watch. So actually rays are projected in the inverted way. You all know it, or whether you all seen it, I don't know. Suppose you can see from one behind of your this thing, the theater. So what they do is they project the light in the inverted form, so that the image formed on the screen is L. That means it is proper to U. So they project it invertedly, and then the image formed over there will be nothing but the real image that is properly seen for you. So that is an example for a real image, and the virtual image is an example of your own reflection in the mirror. Okay, so let me know if you have still any more doubts, so we'll clear it out as soon as possible. So continue with this topic and move on to the next topic, the next chapter, and we'll wind up the portions as soon as possible. Let me know if you have any doubts. Okay, thank you.